picking up from the last video, we set up a right angle triangle and we got these two formulas. So we can manipulate them a bit. So we can bring the r up and we'll get r sine theta equals y, and again bring the r up, so being divided over here, so multiply it then on the other side of the equation, cos theta equals x. So now we have two equations to find y and x, because we know what r is and we know what theta is. So r is 4.2 and we have the sine, remember, of minus 68.2 degrees will equal y. And then over on the other side, we'll have 4.2 cos of minus 68.2 degrees will equal x. So then that will give us two values for x. Y will equal minus 3.89 and x will equal 1. Just skipped ahead there. 1.56. And we get them two values. We're not done yet, but we want to check, does that roughly match up with our sketch that we've drawn? Does it make sense? Well, we're saying the y value is down minus nearly 4 points, and our x is over along the positive 1.5 points. So roughly the scale, we know the swing is in the right quadrant, and it makes sense. So now to put that into Cartesian form, because that's what the answer or the question asks for, so we got to make sure we finish it. So Cartesian will equal, we have a real number, which is 1.56, the x term, because it's along the real axis, and then we have minus j times our imaginary number, 0.89, so that's along the imaginary j-axis, and there is your answer. So it's very useful knowing how to go from polar to Cartesian, and you can go backwards as well, just using this diagram here. Just very important, a couple of things to note. The swing, if we're swinging this way, around to the left from the real, we're getting a positive angle. The underneath down, we're getting the minus. And I usually use the y-axis or the j-axis to help me there, the imaginary one, because it's positive up here, so I'm swinging up the top, I'm getting a positive, swinging down the bottom, I'm getting a minus. Always try and make your angles with the real axis. It's probably the easier way to go. If we had one swinging over here, it's a good idea to make up the triangle with the real axis, because it can save you a step, save you a shorter step in the long run. But that's how you do polar to Cartesian. And again, you can use similar theories to go back from Cartesian to polar. These formulas here of Pythagoras and SOHCAHTOA are very important, so make sure you're familiar with them. And again, keep your angles in degrees if that's what you're asked for, so make sure your calculator's in degrees, and know how to work with sine, cos, tan, and indeed the inverse sine, cos, and tan. Also very useful to check your answer on the calculator. We showed them functions in class, how to do it, so you can use your calculator to check your answer. But again, you need to show all this working out to get all the marks in the test. So do keep that in mind. Alright, hope you found this helpful. And that's us for this video.